All right, so if you're looking at finding y, what I did was I worked in this triangle, everything in black is given, right? So I thought let's use sine rule because I have the opposite angle to y, and then I had one side and I could find that angle there. I did angle sum and triangle with that one. Right, so that's what I did first. I'm just going to show you on the picture. If I always say, see triangle first, and then unless it's very opposite. So CBD was 70 degrees angle, sum and triangle, and then I used the triangle to get y. So y over sine of the opposite angle is 11 over sine of the opposite angle there, times 70. So guys, the thing here, I think I did it round off here, but now y is one of your final answers, right? They asked for x and y. So because y was one of the things that they asked you for, this counts as a final answer, so you can round this off. So if you wanted to, you could have just worked with 10,34 in your calculations for not, or you could have worked with the unrounded value. I think I worked with the unrounded value, but it would have been fine if you rounded it. So you can round it. So then for x, I don't think you guys thought of using exterior angle. Maybe you did angle sum or angles on a straight line and then angle sum and triangle. That also would have gotten you that one. But to get x, again, I thought of using sine rule. I said x, I have the opposite angle, and then we calculated y, so I just needed that opposite. Right, in order to use sine rule for x. So that's what I did. I used exterior angle of the triangle. So to agree that 48 is the exterior angle of this small triangle, right? And that must be equal to 27 plus something, should give you 48. So that angle A was 1. And then again, I said x over sine of the opposite angle is 10,34 over sine of 1. All right. That's right. This one is your right. Okay, 2.1 was a bit of a steady one because they were just kind of a one-step thing. All right, they wanted BC. Did you guys notice that you could use cardinal straight away because you have the other two sides and the included angle. So BC squared is x squared plus y squared minus 2x times y times cos of the included angle. I'm moving now. And then we get BC on its own, you just have to do square root. Yes. Yes, yeah, I would do that in part. Right, 2.4 was hectic. I don't know if you guys were able to do 2.4. Remember the one thing though, the hint that I gave you beforehand is to find the common side. So did anyone at least try to find CV? Guys, if you don't know what to do with these questions, common side. Okay, 99 out of 100 times that is what you need to do. So yeah, sorry, we didn't do an example quite like this one. So when I was also doing it, I thought, oh yeah, I don't know if you guys will be able to do this one. So I'll give you some time to copy it down, but let me just quickly run through all the steps. Okay, so for me, so this is kind of going to count as an example. So I'll just let me explain it, and then I'll give you time to copy it down. So we need to find, what was it again? BC, right? Which is this side over here. And BC is in a right angle triangle. So for the triangle, we can use sine cos tan. Okay? This is a non-right angle triangle, so here we have sine or cos. The common side is CD. Right? Do we see that? Common side is CD. So what can we do in order to find the common side here? Can I use sine rule? CD over sine of the opposite angle is A over sine of the opposite angle. Right. So guys, like I said, if you don't know how to do the rest of it, you could have found CD just using sine rule. Okay, so that was my first line there. CD over sine alpha is A over sine beta. Right, then I moved my sine alpha over to the other side, and then I did what I showed you guys yesterday. Sine alpha is the same as sine alpha over 1, so I wrote it as 1 fraction. Okay? Now, what we need to do is, because now we have CD, right? So we can work with that. Now we need to work in this triangle, which is a right angle triangle, but guys, we do need an angle. At the moment, we only have the 90-degree angle. Okay? So I decided, let me find that one. Do we see that this angle is an exterior angle of that one? Right? And the exterior angle is equal to the sum of the opposite interior angle. So this angle here is going to be alpha plus b. Right? Exterior angle of triangle. That's the other thing with these questions. If you don't know what to do, see if you can find some angles and write this down. Okay, because if you maybe realize, oh, I can find B and C, either using exterior angle or from that one, using angle, sum, and triangle, and then that one using angle of a straight line, you would get a mark for doing that. Okay, so if you don't know what to do, common side and find any angles. Okay. Right. Then from there, guys, this was the tricky part. Now we have to find BC, but now this is a right angle triangle. So I have this angle. I want to find BC, which is the opposite side, right? I have CD, which is the hypotenuse. Which trig ratio works with opposite and hypotenuse? Sine. Okay, so that is what I did there. Sine of that angle, which is an angle in brackets, but that's fine, it doesn't matter. Sine of that angle is opposite over hypotenuse. Remember, we're trying to find BC. So I made BC the subject by multiplying by CD. Right? Even if you can get to this point, guys, that's all that great. Okay? Now, what did I do next? We said here that CD was equal to this whole thing, right? A sine alpha over sine beta. So now I replaced CD here with A sine alpha over sine beta, right? Times sine of that whole thing. And again, just like we looked at yesterday, this is sine alpha plus beta over 1. So from there, I just put the two numerators together and the two denominators. Okay, we are going to do another example like this now. We're going to write down step by step, yes?
That is sine like DC over angle B and then T over angle B.
Yeah, and then sine 90 is 1. Yes. You will not been allowed to use sine 90. Okay, that's kind of makes sense, right? So I'm going to say again, common side, and any angle that you have to identify. And this is the thing that we're going to practice today, right? Working with variables in multiple triangles. Because this is kind of the most difficult type of question. I'm just going to highlight CD here. So make sure that you copy that down into the Hello.
What?
Where were you, sir? Okay, no problem. Ah, that's fine. I hope you feel all right now. Mm. Okay, you guys done? Copying that down. Yes. All right, 1.3. Hey, you also had to do. Circle one. Are there any questions there before we move on, guys? Like I said, we are going to do another one like that just now. Okay, for 1.3, I also just wrote a little thing there at the top of like my thought process. So we have to find x, which was that angle up there. Now the first thing that I noticed when I looked at this picture was in this triangle over here, we have all three sides, right? And what can we do if we have all three sides in a triangle like that? We can find any angle, hey, using cos rule. You guys remember, cos rule is a way. If you have all three of the side and no angle, you can find any one of those three angles. Okay, so I looked at the fact that I needed angle D, and then I thought this is clearly, don't know how clearly, but this is the cyclic quad, right? A, B, C, D. Do we remember the opposite angles of the cyclic quad add up to 180? So I thought let's find angle B using cos rule in this bottom triangle because I have all three sides, and then I can just subtract angle B from 180 to get me angle D. Okay, so that's what I was writing there at the top. Find angle B using cos rule and then angle D using opposite angles of cyclic quad. Obviously, this in blue you don't have to write. It's just I'm just explaining what I was doing. Okay. So guys, we did a note on this, but it was a while ago. If you want to find angle B using cos rule, remember the way that you set it up, you're going to put at the top of your fraction the two sides that are next to angle B, you're going to square and add together, and then you're going to minus the side that's opposite angle B. Remember, the one that you minus is the one that's opposite, always. So if I wanted to find angle A, guys, I would do 3 squared plus 10 squared minus 9 squared. Okay, it's always the one that's opposite, that you're minusing. So I'm minus 10 squared, and then at the bottom it's 2, and then again times the two sides that are next to that angle. So the only time that you actually use the side that's opposite the angle that you're wanting to find is where you are minusing. Okay, so the rest of it is just the other two sides. From there, when you type that into the calculator, I was distracted. I used to calculate on my phone. You guys are so, I managed to do this one. Let me just check quickly because, no, why I feel like my phone maybe will not. Let's check. Okay, negative 0,185, blah, 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 yes. Now guys, this is negative. Where is cos negative? Quadrants 2 and 3. Can we possibly have a quadrant 3 quadrant 3 angle in a triangle, a 180 plus? No, so that's why I drew a line to that bottom part. Okay, we have to have a quadrant 2 answer, quadrant 2 angle. So I got my reference angle, I just wrote this so that you remember when you do your reference angle, it's always a positive angle, positive value rather. That was 79.32. But angle B is then going to be, because the second quadrant, 180 minus that. Okay, so 100.67. That's angle B. Then for angle D, you still have to say 180 minus, and then your reason is opposite angles of sine. So it kind of looks like we're doing the same work twice, right? Because we had the answer there, but I just still have to go through all the motions. You have to show what angle B is by doing 180 minus, and then you have to show opposite angles of sine. We're taking on this one. We are going to do a prove that example, so that's what it is at the bottom, example, and then prove that. So that's the next heading. So you can put everyone to finish copying that down. You can write example, and then colon, prove that. All right, let's take a look. Can you please copy that down? Yeah, okay. Okay, now guys, here I put in a heading to prove that because it's a specific type of question that people usually struggle quite a bit with. Just because it looks so complicated from the start, right? But what they've actually done here is they've told us what the answer should be. Okay, so they've basically given us an answer. So we need to make sure that whatever steps we take in between, at the or in the end, we need to get to D equal to all of this. Alright, so if we didn't get to that, then we've done something wrong, which is also not the end of the world, but they are telling us what the answer is. It's like in trig where we have to prove that the left-hand side is equal to the right-hand side, right? Remember, we were continuously working towards what they gave us on the right. Same kind of thing here. Okay, they're saying we need to prove that D is equal to this, so I'm just highlighting line D here. That is what we need to find. Okay, so that our method is going to be the same as if they just ask find the letter D. Right, we're going to do exactly the same thing. So that's the same our method. The only thing that's different is that we know what the answer is. Okay. Now this is similar to the question of the 2.4 that we marked in the sense that it's two triangles that are next to each other. Okay, and there's a whole lot of variables. What did I tell you? What do we always need to find? Common side. So that's going to be the first thing that I'm even going to write down. The common side is BC. You don't get a mark for writing that down, but it is nice to just kind of focus in on okay, I need to find BC. Guys, often the question has been asked also, which triangle do we know to start working in? Right? Now, side D, the side that we're meant to find, is in the bottom triangle. Okay, so that means that I'm going to have to start working in the other triangle. That's how it always works. Okay, so I'm just going to write here, D is in triangle, what's that name? BCD. Therefore, start working in triangle, what is it, ABC, I guess, yeah, triangle ABC. If we could just find D by using the bottom triangle, they wouldn't have given us the top one. It just have given us the bottom triangle. The fact that they've given us two triangles and D is in the bottom triangle means that we're going to have to use that top triangle to find the common side. Okay. Now let's go back to the top triangle. What type of triangle is triangle ABC? It is a right angle triangle. So we're going to try and use sine, cos, or tan. Okay, I'm just going to write here triangle ABC is right angle equal use sine, cos, or tan. Now remember, we're trying to find the common side. So we look at our triangle, we look at the angle that they've given us, which is theta, right? The common side is the adjacent side. Do we agree? Did they give us a side in that triangle as well? They gave us K, which is the opposite side. Alright, so we have theta, we have the opposite side, we're looking for the adjacent side. Which figure is that opposite and adjacent? That's tan. So we're going to say tan theta is equal to opposite, which is K, over adjacent, which is BC. Remember, we want to find the common side. We want to find BC. So now, unfortunately, BC is in the denominator. So we're going to have to do an extra step where we first get it out from the denominator. So we're going to have BC times tan theta. You can put the sign symbol there if you want. Equal to K. So what is BC then equal to? I want to get BC on its own. What must I do with the tan? divide. So BC is going to be equal to K over tan theta. And I just look at what we're meant to get in the end. Right, we're meant to get D is equal to something, but look, there we have our K at the top already, and there we have our tan theta at the top. Okay, so we know that we're on the right hand. We have the part of the numerator and the part of the denominator already, just by finding the common side. So once you found your common side, you're now going to work in the bottom triangle to get D. Alright, let's see if we can use sine rule. Guys, the bottom triangle is not a right angle triangle, right? So we have to use sine rule or cos rule. So if I want to find D, do I have the opposite angle? Yes. Then do I have another pair of sine and angle that I have? Remember we found BC now, hey? We have that side? No, I don't have the opposite angle, but can I find the opposite angle? Yes. Okay, so that's going to be the next step. So we need to find angle BDC. Now guys, I also want to urge you to leave a space if you're starting with like a completely new kind of calculation, right? Just for your sake as well. So now I found BC, now I'm doing the next thing, so I'm leaving a line. Okay, it's not going to lose the mark. It's just part of what's going on. So BDC is going to be, and now remember the example that we did yesterday, guys, because we're going to use sine rule. Let's write this angle as 180 minus, and then in brackets, alpha plus b. Okay, because remember when we're going to do our sine 180 minus, we can use bracket formula. Reason, angle sum in triangle. You can leave it like that for now. We're going to drop that 180 minus the word of the sine. Okay, now we can use sine rule in this triangle. So now we're going to say D over sine of the opposite angle, which is beta. Right, D over sine beta is DC over sine of this whole angle. Now guys, I'm not going to write this yet. I'm going to just write BC. Okay, don't make it too complicated too quickly. I know that BC is a fraction, but don't write that fraction yet. Just say BC over sine of this whole 180 minus thing. What I also want us to avoid is to put fractions within fractions. Okay, so also don't do that. When you have this now, don't put K over tan theta now at the top. Okay, don't be wrong, it's just going to make it very complicated. So an easier way of doing it, let's leave this as BC for now. 180 minus is which quadrant again? 180 minus quadrant 2. Hey, what is quadrant? Oh, sorry, not cos sine in the second quadrant. Positive. Okay, so we're going to leave it as sine of just that bracket. We're going to drop the 180 minus. Okay, so we're going to have sine of alpha plus beta, and that's BC over that. I'm still not going to change BC to K over tan theta. I'm going to move that sine beta over to the other side first. All right? Remember, if we want to get rid of the sine beta, we need 2 times it on the other side. Okay, so I'm going to have D over here equal to this fraction again. Times sine beta. And what is sine beta equal to? Sine beta over 1, hey? So now I can write it as 1 fraction. I'm still not replacing BC with that fraction. I'm trying to not make it complicated. Right, I'm keeping it as simple as I can. So BC sine beta over sine alpha plus beta. Okay, now I'm going to show you guys a trick. All right, what we're going to do now, because BC is this whole thing up here, hey, I don't want a fraction within my fraction, okay? What I'm going to do is, I'm going to take BC out of this whole fraction. If you agree with this, let's see now, we can recognize that it's the same thing, just written in a different way. Okay. BC is the same as BC over 1, right? So do you agree that if I had this, then I would know that, okay, I can just take BC sine beta at the top and sine alpha plus beta at the bottom. Now, why does this actually make things easier? Because it's an extra step, right? And I mean, it's extra writing. Now, once you have your BC separate, remember what was BC? K over tan theta times sine beta over sine alpha plus beta. And now, what do we do with the numerators? We times them together. So what am I going to have at the top? K sine beta. And at the bottom, I can just times these together. Tan theta and sine alpha plus beta. All right, so now we're just going to put those two fractions together as one fraction. I'm just going to write my denominator first because I just have to space into the out. And if you go back up, it's not on the screen now, but this is what they wanted us to prove, right? I think the tan theta was just at the end. But it's one term, guys. These two, you can times them together, you can swap them. Okay, loads and loads of steps. I think that's the issue with these questions, right? Is the fact that there are so many steps here. But yeah, just do it one step at a time. It does take a long time, obviously, to write these steps out. But yeah, in terms of the maths, is there any steps here that we just want to go over again? I think the best way to do now will be to start to practice one or two on your own. Okay. Again, I'm going to say common side, any angles that you can find. All right. Once you found your common side, I'm going to come back down to this now. Once you found your common side, you're then going to use the common side in the other triangle. Okay, so I've got these here, so you have to use that common side. Okay, all right. I'm going to give you guys 2.5 is one that's very similar to the one that we've just done. Then 1.2 is also, so 2.5 does not approve that question, but it is a question where you have two triangles next to each other and you have to do the common side that situation. 1.2 is approved that question, but also two triangles, and you must find the common side and then the next one. And then question 2, we'll see how long this takes you guys. I might take away question 2, we'll see how it goes. You do have to practice it. Yeah. I'll just put the one because they're on different pages. Oh yeah, sorry, I wanted to check the page number for the next one. Let me just see quickly what that page number is. Exercise 7 is on 226. Let me add that. 226. Right, just copy that down quickly. And guys, for question 2, 3.2, where they're saying AC, let's see if you go to your book, they put y minus x, it should be an x minus y. So just change this in the books, please. That is meant to be x minus y. It's y minus x. If you have your textbooks, can you just change that? Okay, let's put 2.5 on the board. Okay, there's 2.5. For 2.5, they want you to find BC. All right, so the question is not there. Oh, sorry. For 2.5, they want to find BC in terms of all those variables. Can you see how it goes? And okay. No, no, sorry. Sorry. So you can add rows. You're finding BC here.